I'm here to talk to you today about the benefits of moving to a VSI version of OpenVMS if you're on Alpha or on Itanium. By now, maybe you know our vision. By linking the past to the future, we provide OpenVMS users an opportunity to protect and realize the full value of their application investments. Now, we believe that the best way to protect and realize that value of your application investments on OpenVMS is to move to OpenVMS on x86. We also realize that a lot of our customers are not quite there yet. They may need some help, and in some rare cases, it may actually be impossible. Well, nothing's impossible. It may be cost prohibitive, for instance, if you've lost your source code to migrate. But even if you cannot go to x86, we believe that there are some really good benefits in moving to a VSI version of OpenVMS on the older platforms. So I'm going to talk about some of these. I want to talk about long-term support, enhancements to security, more modern features. Then I'll provide you with some resources to check out our offerings. And if we have some time left at the end, I would like to use that for questions, maybe a little bit of discussion where, we know that there's a wish list of things on Alpha and integrity. And if we can get some clarity around that in the last part of this presentation, that would be great. So talking about long-term support, is there anyone here who is still on an HPE version of OpenVMS? Okay. Any idea when the last time is when you got a patch for your version of OpenVMS?
Can't remember so long time.
The last patches for HPE versions were in mid-2019. That means you have been without getting critical fixes for 6 years. Of course, OpenVMS is such a stable operating system that you can probably keep running for a while. But the reality is that the world around us keeps changing. New ways to exploit flaws are being found, and that leaves you vulnerable if you are without support. VSI versions of OpenVMS, we extended our support roadmap this year to go out to 2035. And every year we will add another year to the roadmap so that you can see where you are in terms of support for the next 10 years. So right now we have said our Alpha and Integrity versions are, the latest version is going to be on full standard support until 2035 at least. Next year, when we come up with a version of this roadmap that goes to 2036, we will most likely extend those bars because we realize that 10 years from now, there will still be customers running on Alpha and Integrity. Now on Alpha, of course, you have the option of running on the emulator, which means that the lifespan of that platform will probably continue longer. The viability of running on Integrity, where the only platform you can run on is real hardware, at some time, the last alphas that HPE sold will start to break down. It will become difficult to find replacement parts. So for customers on Integrity, I think there is a larger imperative to move to x86. Let me talk about some of the other benefits of coming to our versions of OpenVMS. On VSI versions of OpenVMS, even on the older platforms, provide some enhanced security features. And we've made changes in the TCP/IP stack. And the version of the TCP/IP stack that you can get on Alpha and on Integrity today is the same as the version of the TCP/IP stack that we produce for x86. We haven't done all that work that we're doing there exclusively for x86. We released the same version for x86, Alpha, and Integrity. The same goes for OpenSSL, and the same goes for OpenSSH. If you are on an HPE version of OpenVMS, you are stuck with TCP/IP services and the SSH version that comes with that. Cryptographic algorithms are evolving all the times, and flaws are being found in older algorithms. And with computers getting ever faster, something that could not be broken in terms of encryption 20 years ago, when these algorithms that are standard in OpenVMS were invented, now those algorithms can be broken. If you're not moving to the OpenSSH-based SSH, you are missing out on those improvements. And you may not worry about that too much, but if your IT department has a policy that these older cryptographic protocols need to be disabled on Linux systems, on Windows systems, it's going to break your ability to communicate with your OpenVMS system. In OpenSSH version 9.9, or in OpenSSH version 9, which has been like the latest version for the last few years, the support for DSA, the key algorithm that is used on with SSH on OpenVMS, was deprecated. Actually, it's been deprecated for 11 years, but in this version, they have made it default not enabled at compile time. You can still enable it if you compile OpenSSH from scratch. And we are porting OpenSSH version 9.9.2 now, and we are enabling that because we know that backwards compatibility is still important. But with the next version of OpenSSH, version 10, that support is going to be removed from the code base entirely. That means that when your Linux or Windows systems update their SSH implementation to OpenSSH version 10, there is no way for those systems anymore to speak the older protocols that are required to communicate with the old SSH. That is something that should probably concern most people. We've also made some improvements to password management, and we will continue to do that. Samba, we've got newer versions of Samba that are compatible with like newer versions of the Windows version of that protocol. So if you exchange files with Windows systems using Samba, being on a VSI version of OpenVMS will give you access to those later versions. We're also porting a lot of software to OpenVMS. So things like newer versions of Apache or Civet Web, programming languages like PHP and Lua, we have versions of that available for our version of OpenVMS that are much more modern than what is available for HP VMS. Database stuff like Redis, which is like a very fast database in memory, like an in-memory cache. A more modern MariaDB client, a Postgres client. All sorts of utilities like CURL, GSOAP, RabbitMQ. There's a lot of stuff that we have ported from the open source world, and we have not just done that for x86. Where possible, we're making the same products and the same versions available across all three architectures with the exact same capabilities. There are some notable exceptions. To address the elephant in the room, Java. We don't have a Java version 8 or newer for alpha. And I'm sorry to say, but we never will. It is just not going to happen. The support for the alpha architecture as a target of code generation in Java was removed a long time ago, I think in Java 1.5 or 1.6, something like that. And to add all that back, if a customer came to us and says, we will pay you $1 million to do it, then we would start the investigation whether $1 million would be enough to do it. But I don't think we could possibly do it for less. I was part of porting Java 8 for Itanium. We didn't have to do the code generation end of it because that was already done for HPUX. If we had also had to do like the code generation part of it, it would have been a huge project, and we could not have done it in the year that it took us to do that. So Java is not happening. So some of the resources that we have available, if you want to learn more about this. If you go to our website, and you can also find this through the menu, but there's a page, OpenVMS on Alpha and Itanium. The address is products.vmssoftware.com/upgrade. And from there, you can choose Alpha or you can choose Itanium, and you get an overview of the benefits of the VSI offering on that platform. We also have our roadmap, and our roadmap lists everything that we're working on, everything that, I'm sorry, no, it does not list everything we're working on. It lists everything that we're working on that we are sure we can release in a reasonable amount of time. We have a lot of things that we're working on in the background where we're not quite sure yet. Is this something that we will have available next year? Is it something we'll have available the year after that? Those things generally are not on our public roadmap. We have an internal roadmap that's much thicker than the external one. But the external one should show you, if it doesn't say anything in specific, what we're working on is for all three platforms. We offer a free upgrade analysis. If you are running on an HPE version of OpenVMS on Alpha or Itanium, it is very unlikely that there is something in your system that would prevent you from going to a VSI version of the operating system. But we also realize that for a customer, assessing the veracity of that statement can be difficult. So we offer the service for you. It's free of charge. And we will take a look at your Alpha or your Itanium system, and we will tell you whether it's okay for you to go to our version of the software or not, or whether some work would need to be done either by you yourself or by us to make that possible. We also offer evaluation licenses. You can contact our sales team, describe your situation, and they will set you up with evaluation licenses so that you can test drive our version of the operating system and layered products, open source, whatever you want, for a few months so that you can see whether this works for you or not. If it doesn't work for you, we just part ways after the evaluation license is done, and maybe next year when we have further improved our offering, we do have something that works for you. And of course, best way to contact us is just to go to our sales department. Jan is sitting here. I think I saw Adam, but sitting in the back. Adam, do you want to stand up? Adam is our new head of sales. So he's gradually stepping into this role as Jan is taking a step back this year. So he deals with a lot of European customers. Adam speaks a a lot of different languages. So if you call him, you may be able to have a conversation with him in your own language, even if it's not Danish or English. So these are some of the things that you can look at if you're considering moving to VSI OpenVMS. So there isn't a whole lot for me to tell, except to say that most of what we do for x86, we also do for Itanium and for Alpha. And I realized that in our messaging, x86 has been front of mind most of the time. And that is, of course, because we would really like our customers to go to x86, because that is where the long-term future is. But don't feel like you're stuck on an HPE version just because you're still on Alpha or on Itanium. With that, we have plenty of time left to answer questions, maybe enter into a little discussion. You can give me your list of things that you would like to see in OpenVMS. So, who? Here.
Camiel, the forthcoming TCP/IP v7.
Yes.
Will that be ported to Alpha and Itanium?
That is still a matter of debate. So with TCP/IP version 7, we are trying to get that out as quickly as we can. And the main driver for getting it out quickly is that we want to make it possible to have x86 clusters with shared storage without having to rely on fiber channel technology, which is unavailable in some. It basically ties you to the hardware, which we don't want to be on x86. For that reason, we are fast-tracking the development of TCP/IP version 7 by focusing on x86 only for now. Once we have completed the port of TCP/IP 7 to x86, because we're taking a new TCP/IP kernel from FreeBSD, once we have completed that and we have released it for x86, that is when we're going to take the decision whether or not we will make this available on Alpha and Itanium. The potential showstopper there might be the kind of support that we would have to add to the C compiler for Alpha and Itanium to simply be able to compile this code, because it uses a newer version of the C language standard than those compilers support. So we would likely have to do some work in the compilers to make this possible. And until we have made a decent evaluation of exactly what those changes would be, we cannot say whether this would be feasible or not. So there are three possible outcomes. Well, there are three possible outcomes for Alpha, and there are three possible outcomes for Itanium. The outcome for the two platforms may not be the same. So outcome number one is the one we all hope for, is that this is completely feasible and that all the features of TCP/IP version 7 will be available across all three platforms, including the capability to connect to iSCSI for your shared storage, which would be great, of course, for mixed architecture clusters. The second outcome is that we can port the TCP/IP kernel and most of the utilities, but maybe not everything. Something like the latest version of bind might not be feasible. So we could have a TCP/IP version 7 on Alpha and Itanium that has most of the things that we have on x86, but has older versions for some parts that we could not port easily. And then, of course, the least desirable outcome is that we find that there are so many things in the kernel itself that we cannot support with the compilers that we simply cannot do it, and that we will be stuck with TCP/IP version 6 on Alpha and Itanium. When we started thinking about TCP/IP 7, we were still considering whether we should do it for alpha and Itanium, even if it did turn out to be feasible. I think we're past that debate, and we've decided that if it's feasible, we will do it. That was a very long answer and maybe not entirely satisfactory, but that's how it is. Anyone else? Yeah.
So I heard that cluster support is something on the line for 86.
We do support clusters on x86.
But not shared disks.
Shared disks using MSCP and shared disk using Fiber Channel. But if you use Fiber Channel with x86, then you need to have a Fiber Channel HBA in your host system that is dedicated to the system. That means that only works on HPE hardware.
And I'm looking at cloud services.
Mhm.
So that basically I want to put it out somewhere.
Right, exactly.
And there I need to have some, and I'm really looking forward to see that you offer the cluster capability with shared disks.
Yes. So if you're running on the cloud, then obviously you're not going to call your cloud provider and say, hey, I need a Fiber Channel controller in whatever system my cloud system runs on, because you don't control that hardware, and Amazon or Oracle or Google will just tell you to go away, please. So with TCP/IP version 7, we plan to support a storage protocol called iSCSI, which is SCSI over TCP/IP. It's very similar. Theoretically, it's very similar to Fiber Channel, but it runs over standard TCP/IP protocol rather than over dedicated Fiber Channel hardware, which makes it much more flexible. And this is something that we can support in the cloud. So if we can have that for all three architectures, it could even enable like multi-architecture clusters in the cloud if you run on an emulator like Stromasys or AVTware.
Then you could have your NAS box if you have it on-prem, like have your storage there.
You could have all sorts of things. Now, a NAS box typically would do like file storage, not block storage.
Yes.
But if you have something that can talk iSCSI, I mean, if you run a simple server with like FreeBSD on it that can serve iSCSI disks, you can either have dedicated hardware to serve your iSCSI disks, like an HP MSA controller with iSCSI ports, or it can just be a regular server or even a virtual machine.
You just add that no CI itself create disks which are served by.
Yes, so OCI, Oracle Cloud, has native iSCSI capability for their storage. So if you use iSCSI there, then you get all the benefits of like Oracle's distributed storage model with iSCSI that you can then connect to from VMS. So for instance, if you have a cluster spread out across multiple data centers, you can talk to like an iSCSI controller in the same data center, but see the same storage from both ends. I mean, for host-based volume shadowing, that would be an amazing setup. Yeah.
Related to this question, the iSCSI protocol, does it support sharing in the way as sharing the same resource in the same way as?
Yes. So the question is, does iSCSI support sharing resources? So the great news about iSCSI is that it is part of the SCSI standard, and it conforms to all the parts of the SCSI standard. So unlike say a TAPI, which is sort of like SCSI mangled onto a IDE interface, iSCSI is real SCSI, and it does support all the things that OpenVMS needs for its sharing model, including like the tagged command queuing, which is often problematic if you're using something that looks like SCSI but isn't quite SCSI. So yes.
Could you, for instance, run a real SCSI on cloud environment, like configuring the two virtual machines with shared disks that are served via the SCSI protocol in the emulation? I don't, it's a matter of the cloud provider. You on Alpha systems, you have the chance to do dual hosted SCSI.
You're talking about parallel SCSI?
With standard SCSI controllers, you put some SCSI disks, you have two SCSI adapters.
Yes.
Alphas, and you have a shared bus and a shared disk environment. Can you run this on a cloud environment?
No, I mean so this is something that you can try. So I'll have to get a little more technical now. So if you were to configure shared storage in either the cloud or in a hypervisor, and you create two emulators and you give them an emulated, or two virtual machines, and you give them an emulated SCSI controller connected to the same volume, you can start your cluster, start running things, and it will look fine until there is some transition in your cluster. For whatever reason, one of your cluster nodes can no longer access the disk, even for a very short period of time. It may be something on the hardware side, unlikely if it's all emulated, but it may also be something on the software side. Something is keeping the system at high IPL just long enough that an IO takes just a fraction of a millisecond too long for VMS's tastes. Now VMS, the disk subsystem, goes into this kind of paranoid mode where it tries to figure out, hey, I've got a cluster. I've got a customer who's got some data on these disks that they're probably somewhat attached to. I better be damn sure that I can still access that disk reliably in the way that I think that I can access it. And if not, I'd rather like crash one of the nodes in the system rather than continue using that disk. And the mechanism it uses for that is tagged command queuing. So the different nodes will start talking to this disk and they will say, I have an IO here and it needs to go earlier than anything else. And if another IO happens in between that, then that's bad. So if you're now on this emulated environment, it may look like it supports tagged command queuing, but it's really emulated. So the emulator doesn't know about the fact that there's another system talking to the same disk. They don't coordinate with each other at the tagged command queuing level. That means the system starts getting the wrong answer from the storage system. And it's like, this is no good. I'm going to bug check. So you have one node that may have a slight problem accessing a disk for a millisecond, and you'll see a few cluster nodes go down until you've lost quorum and your cluster is hanging. You try to regain quorum, so you set your votes to whatever you have left. They will continue figuring out, can I reliably access this disk? Decide no and go down until there's only one memory in your cluster left. That is why it's not a good idea. Anyone else? And I've tried this experiment. My cluster kept running perfectly for like 5 years, and 5 days. And I'm thinking this is really great. And then this weird thing started happening where I lost half my cluster nodes. Anyone else? Any things that you know are not available on Alpha or Itanium, or think are not available that you really miss? Something we need to consider. Yes.
To circumvent this problem, you could actually, I suppose, in order to run VMS machine to MSP or the rest of the cluster.
Yes. Yeah, you can support a shared disk using MSCP, but if that one node goes down, you lose access to the disk. So in that scenario, what's the point of running a cluster? Yes.
Well, I suppose you could run 3 nodes MSCP serving disks from each other their own set of disks and then shadow host, and both you can figure out clever way of routing your freaking MSCP servers so that you reach proper configuration of the shadow set upon encountering a major problem.
I have to give this room an A for creativity. I don't think I would like to see the performance of that solution, but you're right, it would probably work.
I know one customer that is running, actually it's well, it's an x86 Windows system. They are running Caravans on top of it. 2 of those, and they are MSCP serving stuff that is probably using iSCSI from a NetApp. And then they have 4 alpha servers using those disks. There's no volume shadowing in place. And then the main problem seems to be that the Windows guy keeps patching the Windows and rebooting the freaking Windows system, and then the current stays down, and we end up in not verified timeout and have to hard reboot the alphas because there's no remote control access to them. But then again, this is mainly Indian continent maintenance problem because those Windows guys don't understand what they are doing. Why they are killing this open now and then.
Right. Yeah, I feel for you.
Well, it's easy money for me to fix it.
Well, I mean, there's an upside to everything, isn't there? Any other questions or remarks?
So you said this TCP/IP stack, it's gonna be completely, or it's based on something else. So this current TCP/IP stack is more of a continuation of the old HPE or 264 TCP/IP stack.
Yeah.
The new one will be based on something completely different.
Not quite. So our current TCP/IP stack is like 20-year-old code. It came to OpenVMS, as you say, through True64. And True64 is a BSD Unix system. So True64's ancestors are, I think it came from OSF1, and then OSF1 came from BSD. So if we're looking at the network stack as it is, it's the TCP/IP stack, the kernel in OpenVMS consists of code that came from BSD Unix with sort of like this wrapper around it. And the wrapper does things like it takes QIOs from OpenVMS and turns it into calls into the network stack. And it takes packets from the network stack and passes it on to the drivers for the network cards in VMS. So the kernel that came from BSD is obviously written in C. And then the wrappers around it are mostly written in VAX macro. What we're doing is we were looking at this and we're like, we are so held back by the fact that we're running a 20-year-old network stack in terms of the protocols that we can support, because a lot of protocols benefit from having some parts of the protocol running inside the network kernel. And a prime example is iSCSI. Part of the iSCSI protocol is implemented inside the TCP/IP kernel. That makes the performance a lot better. But it means that if we want to port something like iSCSI, we would have to figure out what all these parts are that normally live in the kernel and move them outside of the kernel. It becomes increasingly difficult. So we're like, what can we do to make this easier? Obviously, port a more modern version of the TCP/IP kernel. Could we take from Linux? Technically, maybe we could. Legally, it's tricky because then we start putting things into the VMS kernel that are GPL licensed, and our agreement with HP doesn't allow us to open source VMS source code, and I don't think we would want to do that. So where can we get it? We can get it from another BSD operating system. First of all, yes, things have changed in 20 years, but it's still based on the same code that we got our TCP/IP stack from. It's just evolved and we need to evolve with it. But the interfaces between that stack and the wrapper layer that we have are probably a closer match than any other TCP/IP kernel that we could get. So we're like reporting from FreeBSD. We're modifying the wrapper to accommodate what has changed. We're building a compatibility layer between like the older BSD calls and the more modern BSD calls, so that if you have application software where you directly use these interfaces into the TCP/IP stack, the sockets interface, it will continue to work without you having to update your code, and then we're good to go. But it's still a big project. There was someone here first. Sorry.
Yeah, let's assume that we have got the IP stack version 7 running, and we have got iSCSI running with sharing disks and so on. What about booting from a shared system disk? Then we would need some support in the firmware layer, so to speak.
Yes. Working on it, but will not be available from day one. Yes, I'll leave it at that.
Are we going to get rid of UCX on OpenVMS if you replace the software, the TCP/IP stack, so we get a more modern kind of interface? Because it's very confusing to me, when actually managing the IP stack. I have to get back to 20 years of knowledge, and all the things I've learned the last 20 years, it's not there.
This is one of the things that we're still looking at in terms of design. We likely have to keep the UCX-like interface just for compatibility reasons, because so many users have scripts written around that interface. But if we can offer like a more standard interface besides that,
That'd be great.
yes, but that may be like a phase 2 of the project.
Okay.
We have kind of some of that.
We have some of that, but it's not
It's going to
complete.
gonna be fine come out.
Yes. Yes, that's a good point. If you're not aware of that, TCP/IP $defined commands. It's a command procedure you can run that gives you, it basically defines some executables that are there, but that's most people don't know about.
I have to read command of them.
Yeah, that's a good point. We have some of that, but not everything.
Not everything, but
Right? Yes, sure.
Totally different topic. I heard about the fact you improved the debugging for x86, you had to make it. And I heard time ago that perhaps you could backport the instruments of the debugging to Itanium. Do you think about that?
So when we talk about the enhancements to the debugging experience, and John can say more about this, but what it really is, like the debugging experience on x86 was really bad. And we are working really hard to get that where it needs to be on par with the debugging experience on Alpha and on Itanium. So it's things like, because we're using it mostly has to do with the fact that we now have a new compiler backend that is not, it produces debug information that our debugger is not used to. So it's two parts. It's helping like the LLVM backend that we use on x86 produce the kind of debug information that our debugger needs to figure things out. And it's teaching our debugger to take that information in a format that LLVM produces rather than the format that Gem produces. So because the compilers on Itanium and Alpha don't have that problem, there really isn't anything to backport. If we're going to do things like add more commands to the debugger to do things that even the debugger on Alpha and Itanium couldn't use, then that's a different story. And we might be able to do that or may not, it depends on the case. But right now, and I think John is saying, I don't think there's anything that we could backport today. So yes, by the way, debugging is one part where Alpha and Itanium, it's better than x86 right now. We're slowly getting there. A few small things I think left to do. Support for run doubles I think is one, but we're mostly there now. Yeah.
Going back to the IP stack, anything you can mention regarding the IP stack or WireGuard or any of these VPN encryption protocols?
Yeah, we're like really getting into the keynote session that I'll be doing on Thursday now, because that's about like everything that we're planning for the future. But yeah, so we have a few things that we're hoping to achieve when we get to TCP/IP version 7. One of them, for instance, is support for NFS version 4, which a lot of our clients have been asking us about. And that's one of those things that is difficult to do with our current TCP/IP stack. Another thing we're looking at is IPsec or WireGuard, or maybe even both, which are ways to basically encrypt any kind of DECnet or any kind of traffic. You could even use that to have encrypted DECnet over IP traffic. We're also thinking that we can possibly leverage that to have encrypted cluster communications, where if someone logs into a cluster member, there's no longer a packet flying around the cluster that might have the password in clear text in it. Right now, by the way, if you're running a cluster, it's still good practice to keep your cluster traffic separate from any other network interfaces so that people don't have access to it who don't need to have access to it. So yeah, and there's a whole list of precision time protocol, but also things that require more work. For instance, modern network cards are a heck of a lot faster than the 10 megabit cards or even the 2.5 megabit cards that VMS started out on. And our whole driver model in VMS hasn't really kept up with that. So even with TCP/IP version 7, if you put a 100 gigabit NIC in your system, there's no way an OpenVMS system today is going to be able to utilize that bandwidth. Part of that, for instance, has to do with the fact that we keep network buffers in S1 space. It's a tiny bit of memory. It was huge, of course, in the VAX days, but now it means that the size of our network buffers is severely restricted. We want to move that into S2 space so we can have much larger network buffers. These cards have offload engines. One of the most compute intensive parts of sending a network packet is calculating the checksum that goes at the end of it. Well, guess what? Modern network cards have hardware that does that for you. You just hand it the packet without the checksum and tell the card, add it at the end. There are features like that that we can start making use of once we get to TCP/IP version 7, because then we can start looking at all these different interfaces. It would not make sense to start doing that today because we'd basically be duplicating a whole lot of work for ourselves. So there's a ton of improvements that we're looking at once we get to TCP/IP version 7. Time frame for TCP/IP version 7 is we want to go to field test with that at the end of this year. And then production mid next year. We're taking that will be OpenVMS version 9.2.4 with TCP/IP version 7. And the reason we're taking a longer period for field test is that we know that this is a big change, like adding iSCSI into a cluster. And we really want to take the time to make sure that we have at least a few customers who test with that feature. And also so that if we find something like, say, a month after we've gone into field test, that we can issue like a second field test release so that we can work out more issues before we do the production release.
Is that on the roadmap?
That is on the roadmap, yes. All right, I think we have 3 minutes left.
So one more question regarding.
Yes.
Fiber channel.
Fiber channel, okay.
You said that we need a native fiber channel controller, so we have a VMware with a virtual fiber channel is not possible to handle.
So virtual fiber channel controls, they suffer from the same issue with not having the transparent tag command queuing is our experience. So you need a real fiber channel controller in the host system. And because we only can write so many driver and test so many configurations, that means you have to have a specific HPA in there. And that basically means you need to have it in an HPE server because otherwise it's not supported. And we would really like to be able to tell all our customers, it doesn't matter what you run on, whether it's Supermicro, HPE, Dell, Sun, IBM, you run on whatever hardware platform you already have, and we can support that. And iSCSI will allow us to do that. Yes.
Does that also mean that if you have that HPE server, apparently, say, Linux, KV, and VMware, and you have HPE adapters there dedicated to your virtual machine, that you have to have for each virtual machine.
Yes.
Okay.
Yes. So each virtual machine that uses fiber channel pass-through has to have its own HPA in the machine. So if you're running 3 virtual machines on one host, that host needs to have a minimum of 3 fiber channel cards. And they need to be individual cards. You cannot split up the ports on if you have like a 2-port card, you cannot split those 2 up. That doesn't work because they're on the same PCI bridge.
So, and if I want it redundancy, I need to then have 6.
Yes. Yes, and yes, we do realize that this is a restriction. We still think it beats having to buy 6 servers, the way it was on Alpha and on Itanium. But yes, we realize that that's a severe restriction, but there's no way to overcome that using fiber channel technology, unfortunately.
And one final question, at least for me. So currently on x86 platform, booting the system, I guess, is restricted basically to you can boot one OpenVMS x86 system from one system image or the boot disk because of the way
Yes.
the booting is constructed. There's, well, I can imagine one very workaround for it, but it's not very good and it's probably restricted. Well, it's not very good, but I can invent one workaround.
Yes, your workaround puts the integrity of your system at risk, though. We currently do not support a cluster common system disk on x86. It's a problem we are working on, but it is going to take some time. And there are the the most critical issue is the use of the system disk by the dump kernel. If on an x86 system, if one of the nodes crashes, it goes into the dump kernel. The dump kernel is a full-fledged system that has access to the system disk, and it is not aware of the fact that it's part of a cluster. It will happily start writing its log files to the system disk while the other nodes in the cluster still treat that as their system disk. Not a good idea. So it will work fine with your workaround as long as nothing crashes. But if you shut down a node or if something crashes, then it's bad. Yes.
Possible workaround, which would be on the VMS level. Would it be possible to split up the system disk, like one for booting and maybe for dumping, which is private, but the rest, like where the software is, the configuration and everything, would be on a shared disk?
I don't think that would be a solution. What we are working on is basically having the dump kernel mount the system disk read-only, not write any log files, and for instance, the error log file to a separate device, like a dump off system disk, and then of course the device where you dump to should not be a shared disk. That's the solution that we're working on.
Yeah, but the reason I asked this is why you cannot boot from a shared system disk. It wouldn't matter if you have a small disk just for booting the IP kernel, part of the kernel, or the whole kernel. As long as you can have the shared rest of the system shared.
Yeah, but that would mean like separating where you write your log files to. I think it would break a lot of other existing functionality if you had to sort of like split up your system disk that way. I think a lot of DCL scripts expect certain things just to live on sys or a sys device, and to do that transparently, I would be tricky.
You can link it into the specific route.
I want to thank you for your attention. I think that's all we have time for. But I'm ready to make your thanks.
Detail. There are, I think, most of the Fabergé cards are either QLogic or Emulex. So there shouldn't be a lot of porting issues if you can do.
Well, the trouble is in qualification testing. Every different vendor puts their own firmware on the cards with their own values for things like timeouts and fiber channel credits and things like that. And we have some pretty strict like requirements in VMS, and we cannot go and buy all this different hardware and then do all the qualification testing 100 times. It's not a matter of writing the code. The code should work as long as it's QLogic, because we no longer support Emulex. We only support the QLogic cards. It's been like that for a while, but we cannot take the time to test it on all the different hardware. We'd rather work on iSCSI and give something that works everywhere.
But like they were asking about the booting, and that will be a problem then. External disk.